Welcome back to Nick's Documentaries, where shadows whisper their secrets and the night becomes our teacher. Tonight, we're not chasing UFOs or decoding prophecies. Instead, we're going to ask something that sounds simple but cuts deeper than you might expect. What if everything we know about human history is just the final chapter of a much longer book? What if the pyramids, the megaliths, the unexplained engineering marvels scattered across our world aren't the beginning of advanced human achievement, but the remnants of its ending? I don't mean aliens visited us with laser beams and flying saucers. I mean something closer to home, something more unsettling. What if thousands, perhaps tens of thousands, of years before recorded history, there existed human civilizations that rivaled or surpassed our own? And what if they vanished so completely that all we have left are their bones, scattered across the landscape like broken sentences from a burn library? If this feels like the premise of a fantasy novel, I understand. But it's also a question being whispered in archaeological conferences, geology departments, and late-night conversations between scientists who've seen things that don't quite fit the official timeline. The question isn't whether we want to believe it. The question is whether we're brave enough to look at the evidence without flinching. And before we begin this journey into the depths of forgotten time, I want you to do something for me. Look around you right now. Notice where you are. The walls, the ceiling, the objects that surround you. Everything you see was made by someone. Planned, constructed, left behind as evidence that humans were here, doing things, creating things, leaving marks. Now imagine all of that gone. Not just your room, but your entire city. Every building, every road, every trace of modern life, removed, eroded, buried, submerged beneath rising seas, or crushed beneath advancing ice. How long would it take for nature to reclaim it all? 100 years? 1,000? And after 10,000 years, after 100,000, what would remain? The answer might surprise you, or perhaps it might terrify you, because the truth is, very little would survive. And what did survive might be so altered, so out of context, that future archaeologists might not even recognize it as the work of an advanced civilization. They might find fragments of concrete and dismiss them as unusual rock formations. They might discover plastic residue and catalog it as an unexplained geological anomaly. They might uncover the foundations of our greatest cities and assume they were natural features, shaped by water and wind and time. This is the problem we face when we look backward into deep time. Not just the absence of evidence, but the difficulty of recognizing evidence when we find it. Because we're looking for things that might not look like what we expect them to look like. We're searching for signatures that time has degraded, for messages that erosion has garbled, for proof that the planet itself has been working to erase. Before we dive deeper, I'd love to know where in the world you're watching from tonight, and what time it is in your corner of reality. Strange, isn't it? We're about to discuss civilizations separated from us by tens of thousands of years, and yet here we are, connected across continents in real time, sharing this exact moment of curiosity. Time is a funny thing. It separates us from the past, but it also connects us to everyone who's ever wondered the same questions we're wondering now. If you find yourself drawn to these twilight questions, the ones that mainstream education quietly avoids, I'd be grateful if you'd subscribe and turn on notifications. It's a small gesture, but it helps this channel reach other minds like yours, minds that refuse to accept convenient answers when uncomfortable questions are more honest. And if you're already subscribed, thank you. You're part of a community of seekers, people who understand that the most interesting truths often hide in the shadows between what we know and what we've forgotten. So dim the lights if you can. Let your skepticism and your wonder coexist for a while, and follow me into the fog of deep history. Because before we can ask who they were, we need to understand something more fundamental: how much of history can actually disappear, and why the absence of evidence might be the most important evidence of all. When we think about ancient history, our minds usually stop at a comfortable distance. Ancient Rome feels old, doesn't it? 2,000 years ago, the Colosseum, the aqueducts, the roads that still exist beneath modern highways. Ancient Egypt feels older still. The pyramids, the Sphinx, hieroglyphics carved into stone. Push further back and we reach Mesopotamia, the cradle of civilization, where writing was invented, where the first cities rose from the mud. 5, maybe 6,000 years before the present, that's where civilization began, we're told. That's when humans stopped wandering and started building. That's when history started. But let's pause here and really think about what we're being asked to accept. Let's put that timeline in proper perspective, because once you do, it starts to feel less like history and more like a carefully edited highlight reel with most of the footage missing. Our species, Homo sapiens, has been around for at least 200,000 years. Some genetic studies suggest even longer, perhaps 300,000 years. That's not speculation. That's based on fossil evidence, DNA analysis, and careful dating of archaeological sites from Africa to Asia to Europe. For the vast majority of that time, according to the standard narrative, we lived in small groups, hunter-gatherers, following herds, collecting plants, living in temporary shelters, moving with the seasons. We had fire, we had tools, stone tools primarily, with some bone and wood. We had language, almost certainly, though we can only infer this from the complexity of the tools we made and the evidence of symbolic thought in cave paintings and carved figurines. But we didn't build cities. We didn't develop writing. We didn't create monumental architecture. We didn't organize into complex societies with specialized labor and trade networks. We just survived for 190,000 years. Generation after generation after generation, doing essentially the same things, making the same tools, living the same way. And then, suddenly, around 5,000 to 6,000 years ago, something changed. Boom. Pyramids in Egypt, ziggurats in Mesopotamia, massive stone temples in Malta and Turkey, writing systems emerging almost simultaneously in different parts of the world. Mathematics, astronomy, organized religion, centralized governments, long-distance trade, everything, all at once, appearing in what is, geologically speaking, the blink of an eye. Does that timeline feel right to you? That for 95% of our existence as a species, we did essentially nothing of note, and then in the final 5%, we invented everything. It's not impossible, of course. Evolution doesn't move in a straight line. Progress isn't inevitable. And there are reasonable explanations for why complex civilization might emerge relatively suddenly. Climate change, for instance. The end of the last ice age made agriculture possible in ways it hadn't been before. And agriculture, with its ability to produce food surpluses and support larger populations, is often cited as the trigger for everything that came after. But here's what bothers me about this narrative. It's too clean, too neat, too convenient. It assumes that nothing significant happened in those 190,000 years, that humans were essentially static, unchanging, locked in a kind of cultural stasis where innovation was so slow as to be almost imperceptible. But we know that's not true. We know humans were changing, adapting, learning. The archaeological record, patchy as it is, shows clear evidence of cultural evolution. Improved tool-making techniques, more sophisticated hunting strategies, the development of art and symbolic expression, evidence of long-distance trade in obsidian and shells, burial practices that suggest belief in an afterlife. These aren't the behaviors of a static species. These are the behaviors of minds that are constantly experimenting, constantly pushing boundaries, constantly asking what if. So why would that experimentation suddenly accelerate 5,000 years ago? What was special about that moment? And more importantly, what if it wasn't special? What if civilization didn't begin then? What if that's just when it became visible again, after being interrupted? This is the uncomfortable question that mainstream archaeology doesn't like to address. Not because archaeologists are close-minded, but because the implications are destabilizing. Because if civilization is older than we think, if it's cyclic rather than linear, if we're not the first to reach this level of complexity, then everything we've built our understanding of history on starts to feel uncertain. And uncertainty, for a species that craves narrative and meaning, is deeply unsettling. But let's sit with that uncertainty for a moment. Let's be willing to consider the possibility that the story we've been told is incomplete. Not wrong, necessarily, but missing chapters, missing context, missing the parts that were erased by time and catastrophe and the slow, grinding wheels of geological change. Because archaeological sites keep pushing the boundaries backward, and every time they do, the established timeline has to adjust. Every time they do, we're forced to admit that humans were more capable, more organized, more advanced at earlier dates than we previously believed. Take Göbekli Tepe in Turkey. When it was first excavated in the 1990s, it completely upended our understanding of prehistoric human capabilities. Here was a massive temple complex, covering over 20 acres, with carved stone pillars weighing up to 16 tons, decorated with sophisticated reliefs of animals and abstract symbols. And it was built around 11,600 years ago. That's 6,000 years before Stonehenge, 7,000 years before the pyramids. And, according to the established timeline, it was built by people who were still living as hunter-gatherers. People who, we were told, had no permanent settlements, no agriculture, no organized religion, no reason to come together in groups large enough to quarry, transport, and erect massive stone monuments. And yet, there it stands, or stood, before it was deliberately buried under tons of earth, as if someone wanted to hide it, to preserve it, or to make sure future generations wouldn't forget it. But that's just the beginning. Göbekli Tepe isn't alone. It's not even unique anymore. In the decades since its discovery, archaeologists have found similar sites across the region, all dating to roughly the same period, all suggesting a level of social organization and architectural sophistication that shouldn't exist yet, according to conventional models. And it's not just in Turkey. Across the world, structures keep appearing that are older than they should be, more sophisticated than they should be, aligned to astronomical phenomena with precision that shouldn't be possible without advanced knowledge and careful planning. The Sphinx in Egypt. When you look at the conventional dating, it's attributed to the pharaoh Khafre around 2500 BCE. making it roughly the same age as the nearby pyramids. But some geologists have examined the weathering patterns on the Sphinx's body and come to a very different conclusion. The erosion, they argue, is consistent with prolonged exposure to heavy rainfall. Not wind erosion, which is what you'd expect in the desert, water erosion, deep, vertical channels carved by rain. But Egypt hasn't had that kind of rainfall in at least 7,000 years. Some estimates suggest it might have been twice that long. If the weathering patterns are indeed caused by water, and not by some other process that just happens to look identical, then the Sphinx is much, much older than the pharaohs. It might predate Egyptian civilization entirely. It might have been carved during the time when the Sahara was green, when the region had rivers and lakes and regular rainfall. And if that's true, then who built it, and what happened to them? Off the coast of modern Japan, near the island of Yonaguni, divers have discovered massive underwater stone formations that look unnervingly like architecture. Flat terraces, right angles, what appear to be carved steps, ramps, and channels. The features are too regular, too geometric, to be easily explained by natural erosion alone. And yet, if they are man-made, they would have to have been carved when sea levels were much lower, before the end of the last ice age. That would make them at least 10,000 years old, possibly older. The debate continues about whether Yonaguni is natural or artificial. Most geologists lean toward natural, citing examples of similar formations created by underwater tectonic activity. But even skeptics admit the features are unusual. And the fact that the debate exists at all, that serious scientists are even considering the possibility that these could be the remnants of prehistoric construction, tells you something about how our understanding of the past is shifting. Then there's the question of stone megaliths, those massive blocks of carved rock that appear at sites all over the world, from South America to the Middle East to the Pacific Islands. Stones weighing hundreds of tons, moved distances that would be difficult even with modern equipment, shaped with precision that seems impossible with bronze or copper tools. At Baalbek in Lebanon, the Temple of Jupiter sits on a foundation of stones so massive, they're called the Trilithon. 3 blocks, each weighing approximately 800 tons. That's 1.6 million pounds per stone. Placed side by side with almost no gap between them, fitted so precisely that you can barely slip a piece of paper into the joints. Modern engineers scratch their heads at this. The largest stones moved in contemporary construction, using cranes and hydraulic lifts and carefully planned logistics, weigh around 300 tons. We can move heavier objects, but it requires specialized equipment, months of planning, and a level of precision that's only possible with computer modeling and laser measurements. And yet, someone did this thousands of years ago, without computers, without steel cables, without diesel engines, using what exactly? Copper chisels, wooden rollers, sheer determination, and unlimited manpower? The official answer is always the same: yes. With enough people, enough time, and enough ingenuity, anything is possible. And that's true, up to a point. But at some stage, you have to ask whether we're being realistic or just stubborn, whether we're following the evidence or clinging to a narrative because admitting the alternative would be too disruptive. At Pumapunku in Bolivia, there are stone blocks that look machined, not chipped or carved or shaped with hammers and chisels, machined, smooth surfaces, perfect right angles, interlocking joints that fit together like Lego bricks. And we're talking about diorite and granite, some of the hardest stones on Earth. Materials that modern stonemasons would work with diamond-tipped saws. The local legends say the stones were softened, made pliable like clay, through some kind of plant extract or alchemical process, then molded into place before hardening again. Modern science dismisses this as impossible, as folklore, as the kind of magical thinking that primitive people use to explain things they don't understand. But the stones are there, the precision is there, the interlocking joints are there. And no one, despite decades of study and experimentation, has been able to replicate them using the tools and techniques that were supposedly available at the time. So either the people who built these structures had capabilities we don't give them credit for, or they had help. Not from aliens, from an earlier civilization, from people who came before them, who left behind knowledge, techniques, and possibly even structures that later cultures found, repaired, repurposed, and built around. This isn't a new idea. It's been suggested by archaeologists and historians for decades, though usually in hushed tones, in footnotes, in carefully worded papers that avoid making claims that are too bold, because bold claims require bold evidence. And bold evidence is exactly what's missing. Or maybe it's not missing. Maybe we've been looking at it all along and just haven't recognized it for what it is. Every culture on Earth has a flood story. Every single one. From the Sumerians to the Greeks, from the Bible to the Hindu Vedas, from the indigenous tribes of the Amazon to the Aboriginal peoples of Australia, from the Pacific Islands to the Arctic. The names change, the details shift, but the core narrative is remarkably consistent. There was a world before this one, a world that was prosperous, advanced, perhaps even arrogant. The people had forgotten humility, forgotten their place in the natural order. They had grown proud. And then the waters came. The oceans rose. The rains fell for days, for weeks. The earth itself seemed to rebel. Rivers burst their banks. Coastlines vanished. Entire landscapes were swallowed by the sea. Only a few survived. Sometimes they were warned by a god or a prophet. Sometimes they built boats, massive vessels that could withstand the deluge. Sometimes they climbed to the highest mountains and waited for the waters to recede. And when they did, when the survivors descended back to the lowlands, the world they had known was gone, buried, erased, forgotten. For a long time, scholars dismissed these stories as myths, allegories, symbolic narratives about morality and divine punishment. The flood wasn't real, they said. It was a metaphor for chaos, for the consequences of hubris, for the cleansing power of destruction and rebirth. But then something changed. Geology began to speak, and what it said was unsettling. We now know with certainty that around 11,600 years ago, the last ice age ended, not gradually, not slowly, but in what some scientists call a meltwater pulse. Massive ice sheets covering North America, Europe, and parts of Asia began to melt. Not over centuries, but over decades. And the water had to go somewhere. It went into the oceans. Sea levels rose by more than 120 meters. That's nearly 400 feet. In some places, the rise was even more dramatic due to local factors like land subsidence and tectonic shifts. Coastlines that had been stable for tens of thousands of years were drowned almost overnight in geological terms. Imagine living on the coast during that time. And most people did, because coastlines offered everything a prehistoric society needed. Fish, shellfish, birds, fresh water from rivers. Clat, fertile land for gathering plants, and, eventually, for early forms of agriculture. Moderate climates, access to trade routes by sea. If you were living on the coast 12,000 years ago, your world didn't just change, it ended. The places where your ancestors had lived for generations, where your people had built settlements and sacred sites and accumulated knowledge, all of it disappeared beneath the waves. And there was nothing you could do but retreat inland, carrying what you could, mourning what was lost, and telling your children stories about the world that was swallowed by the sea. This is not speculation. This is geology. This is fact. The flood myths aren't fantasies. They're memories. Distorted, yes. Mythologized, certainly. Passed down through countless generations until the details became confused and the timeline blurred, but rooted in something real. Something traumatic. Something that reshaped the world and the people who lived through it. And here's the crucial point. Most of the world's current coastlines were dry land during the Ice Age. The continental shelves, those relatively shallow underwater areas that extend out from the continents before dropping off into the deep ocean, were above sea level. They were habitable. They were, in many cases, the most desirable places to live. And now they're underwater, buried under centuries of sediment, hidden beneath hundreds of feet of ocean, out of sight, out of reach, out of mind. So, when we say there's no evidence of advanced civilizations before 5,000 years ago, what we're really saying is this. We haven't found evidence on the land that's left. We haven't looked under the oceans. At least, not thoroughly. Not systematically. Not with the kind of resources and technology that would be required to properly survey the submerged continental shelves and river valleys and coastal plains that were once home to who knows how many people. The truth is, we've barely started looking. The ocean covers 71% of the planet's surface, and we've explored less than 10% of it. Less than 10%. Most of the seafloor remains unmapped, unsurveyed, completely unknown. We have better maps of Mars than we do of our own ocean floor. And yet, in the tiny fraction we have examined, strange things keep appearing. Sonar anomalies, unusual formations, structures that look too regular to be natural. And while most are eventually explained as geological features or mistakes in the data, some are not. Some remain unexplained. Some sit in the archives, labeled as curiosities, waiting for someone to take a closer look. Off the coast of Cuba, in 2001, a research team using sonar detected what appeared to be a complex of geometric structures at a depth of over 2,000 feet. The images showed smooth surfaces, right angles, what might have been pyramids or platforms. The researchers were excited. They announced their findings. Plans were made for follow-up expeditions with underwater vehicles that could capture higher resolution images. And then, silence. Funding dried up. The follow-up expeditions never materialized. The site has never been properly explored. The images sit in a database somewhere, unexplained and largely forgotten. Why? I don't know. Maybe the initial readings were misinterpreted. Maybe the features turned out to be natural after all. Or maybe, just maybe, the implications were too significant, too destabilizing, too challenging to the established narrative. In the Gulf of Canbay, off the coast of India, sonar imaging has revealed what appear to be structures spread over an area of 5 square miles, now submerged under 120 feet of water. Researchers brought up samples, wood, pottery, man-made objects. They sent them for carbon dating, and the results came back, suggesting ages of over 9,000 years. If confirmed, that would make these structures older than Sumerian civilization, older than ancient Egypt, older than anything in the accepted historical record. It would mean that people were building organized settlements, creating pottery, engaging in the kinds of activities we associate with civilization, thousands of years before we thought civilization existed. But the findings have been controversial. Some scientists question the dating methods. Others suggest the artifacts could have been washed into the area from elsewhere. The debate continues. And while it does, the site remains largely unexplored, its secrets still hidden beneath the water and sediment. This is the pattern. Over and over again, anomalies are found, excitement builds, and then, for various reasons, funding, skepticism, political complications, the research stalls. The questions remain unanswered, and the mainstream narrative continues unchanged, not because the evidence has been disproven, but because it hasn't been pursued with the rigor it deserves. But it's not just about underwater sites. The myths themselves contain information that's harder to dismiss. Consider the Aboriginal peoples of Australia. Their oral traditions, passed down through tens of thousands of years, contain detailed descriptions of the Australian coastline during the Ice Age. They describe land bridges that once connected islands. They speak of places that are now underwater, and when researchers have compared these oral accounts to what we know from geology and sea level reconstructions, the accuracy is startling. These aren't vague stories. They're precise geographical descriptions of a landscape that hasn't existed for over 10,000 years. How did this knowledge survive? How was it preserved through so many generations? And if the Aboriginal peoples could preserve such detailed memories of ancient coastlines, what else might be hidden in their stories that we've dismissed as mythology? Or take the story of Atlantis. Yes, I know, Atlantis, the lost continent. The fantasy island that's been the subject of countless books and documentaries and crackpot theories. But let's set aside the sensationalism for a moment and look at what Plato actually wrote. According to Plato, Atlantis was a powerful naval civilization that existed 9,000 years before his time. That would place it around 11,400 years ago, right around the end of the last ice age, right around the time of the meltwater pulse. Plato describes it as an advanced society with sophisticated engineering, a powerful military, and control over trade routes across the Atlantic. And then it was destroyed. In a single day and night of misfortune, Plato writes, Atlantis sank into the ocean. Earthquakes, floods, catastrophic destruction, and afterward, nothing remained but impassable mud and shoals. Now, most scholars believe Plato made this up, that Atlantis was a philosophical allegory, a cautionary tale about the dangers of imperial ambition and moral decay. And maybe they're right. Maybe Plato invented the whole thing. But what if he didn't? What if the story of Atlantis, like the flood myths, is a distorted memory of something real? Not a continent, perhaps, not an empire that spanned the Atlantic, but a civilization. A real civilization that existed somewhere, built cities, developed technology, and was destroyed by rising seas and geological catastrophe at the end of the Ice Age. Strip away the exaggerations, remove the fantastic elements, and what you're left with is a story that sounds remarkably similar to what geology tells us actually happened. A prosperous coastal civilization wiped out by rapid sea level rise and tectonic instability. Survivors fleeing to higher ground, carrying fragments of knowledge and memory, and centuries later, when the trauma had faded and the details had become confused, those memories became myths. I'm not saying Atlantis was real. I'm saying the idea behind it might be. The idea that there was something before, something that was lost, something that we've forgotten. And if one civilization could be forgotten, how many others might there be? How many cities now lie beneath the waves, their stones and tools and pottery scattered across the ocean floor, waiting to be found? How many stories have been lost because the people who could tell them drowned? This is the uncomfortable reality we have to face. The past is not a complete record. It's not a detailed archive where everything is preserved and catalogued. It's fragmented, it's partial, it's full of gaps, and the further back we go, the bigger those gaps become. But absence of evidence is not evidence of absence. Just because we haven't found something doesn't mean it was never there. It might just mean we haven't looked in the right places yet. Or that the evidence is too degraded, too scattered, too deeply buried to be easily recognized. The myths are trying to tell us something, not the literal details which have been distorted by time and retelling, but the essence, the core truth, that the world has been reshaped by catastrophe, that civilizations have risen and fallen, that we are not the first to build, to dream, to wonder, to ask questions about our place in the cosmos. And if that's true, if there were others before us, and the next question becomes urgent, what happened to them? Why did they disappear? And more importantly, could it happen to us? Let me tell you what it feels like to stand in front of the Great Pyramid of Giza. Because unless you've been there, unless you've actually stood at the base of that structure and looked up at the stones rising above you, it's hard to convey the sheer impossibility of it. The numbers don't do it justice. Yes, it's made of 2.3 million stone blocks. Yes, some of those blocks weigh over 70 tons. Yes, it was the tallest man-made structure in the world for over 3,800 years. But numbers are abstract. They don't capture the visceral experience of being there, of placing your hand on those stones and trying to imagine the logistics, the engineering, the sheer human will required to create something of that scale and precision. The conventional explanation goes like this. The pyramid was built as a tomb for the pharaoh Khufu around 4,500 years ago. It took approximately 20 years to construct, with tens of thousands of workers hauling stones from nearby quarries, dragging them up ramps, and somehow positioning them with incredible accuracy. But let's do some simple math. If the pyramid was built in 20 years, and it contains 2.3 million blocks, that means workers would have needed to place approximately 115,000 blocks per year. That's 315 blocks per day, about 13 blocks per hour. Assuming a 10-hour workday, which is probably generous, that's one 2.5 tons block placed every 4.5 minutes, every single day, for 20 years. No breaks, no mistakes, no delays for weather or tool maintenance or human fatigue. Just constant, relentless, perfectly coordinated construction, day after day, year after year. And that's just the placement. That doesn't account for quarrying the stones, shaping them, transporting them from the quarry to the construction site, lifting them into position, achieving the precise alignment that exists throughout the structure. Modern engineers have tried to replicate it, using modern tools, modern equipment, and modern knowledge. And they can't do it. Not at that scale. Not with that precision. Not in 20 years. Some have built small pyramids using traditional methods as experiments. And yes, it's possible to move large stones with ramps and rollers and enough manpower. But scaling that up to 2.3 million blocks, many of them weighing dozens of tons, the logistics become absurd. The ramps would have to be miles long. The workforce would have to number in the hundreds of thousands. The organizational complexity would rival modern megaprojects. And yet, we're told this was done by a Bronze Age civilization with no iron tools, no wheeled vehicles, no pulleys or cranes. Let me be clear. I'm not saying it's impossible that the ancient Egyptians built the pyramids. They clearly had a role in their construction. There's evidence of Egyptian workmanship throughout the complex. What I'm questioning is whether they started from scratch or whether they built upon something that was already there, something older, something that came from a time and a people we've lost to history. Because there are details about the Great Pyramid that don't fit the tomb narrative. For one thing, it's not decorated inside like every other Egyptian tomb. There are no hieroglyphics in the main chambers, no paintings, no inscriptions describing the pharaoh's journey to the afterlife. The inner chambers are bare stone, functional rather than ceremonial. The precision is also unusual. The pyramid is aligned to true north with an accuracy of 3/60ths of a degree. How do you achieve that without a magnetic compass, which hadn't been invented yet? How do you even know what true north is with that level of precision? The base of the pyramid is level to within 2.1 centimeters across its 230-meter width. That's a variance of less than an inch over 750 feet. Again, how? How do you achieve that level of accuracy with ancient surveying equipment? And then there are the mathematical constants. The ratio of the pyramid's perimeter to its height is remarkably close to 2 pi. The ratio of the slope height to half the base is very close to the golden ratio, phi. These aren't rough approximations. They're precise enough that it's hard to dismiss them as coincidence. So either the ancient Egyptians had a deep understanding of advanced mathematics, which they somehow never wrote down or used anywhere else, or the design incorporates knowledge that came from an earlier source. Knowledge that was already ancient when the pharaohs claimed it as their own. But the pyramids aren't the only structures that challenge our understanding of ancient capabilities. There are others scattered across the globe that are in some ways even more perplexing. Sacsayhuaman in Peru. If you've never heard of it, imagine massive stone walls made of blocks that weigh up to 200 tons. These aren't roughly shaped boulders. They're precisely cut, with multiple irregular faces that fit together like a three-dimensional jigsaw puzzle. No two stones are the same shape, and yet they fit together so perfectly that you can't slide a razor blade between them. The stones are made of diorite and andesite, incredibly hard volcanic rock. Shaping them with copper or bronze tools, which is what the Inca are supposed to have had, would take months or years per stone. And yet, there are thousands of them, fitted together with a precision that makes modern stonemasons shake their heads in disbelief. How was this done? The official answer is patience, skill, and unlimited labor. But that answer is starting to ring hollow, because it's not just about moving stones. It's about shaping them with multiple irregular faces that somehow fit perfectly with their neighbors. It's about creating three-dimensional puzzle pieces out of the hardest rock on Earth, using technology that supposedly didn't exist. The Inca themselves, according to their own legends, didn't build Sacsayhuaman. They found it. They repaired it. They added their own stonework on top, which is noticeably cruder. You can see the difference. The lower courses, the massive megalithic blocks, are ancient and precise. The upper courses, added by the Inca, are smaller and less refined. Two different levels of technology, two different time periods, two different peoples. The same pattern appears at Machu Picchu, at Ollantaytambo, at sites across Peru, megalithic foundations, impossibly precise, with later construction built on top. As if the Inca inherited these sites and tried to honor them, to continue them, without fully understanding how they were made. Then there's Göbekli Tepe, which we touched on earlier, but deserves a deeper look. Because Göbekli Tepe isn't just old. It's paradigm-breaking. It forces us to rethink everything we thought we knew about the development of human civilization. The site consists of massive stone circles, similar to Stonehenge, but older by 6,000 years. The pillars are T-shaped, carved from single blocks of limestone, some weighing 16 tons. They're decorated with elaborate reliefs of animals, foxes, lions, scorpions, vultures, snakes. The craftsmanship is sophisticated. These aren't crude scratchings. They're detailed, three-dimensional carvings that required skill, planning, and time. And it was built by hunter-gatherers, people with no permanent settlements, no agriculture, no domesticated animals except possibly dogs. People who, according to conventional archaeology, should have been spending all their time just surviving. Finding food, avoiding predators, dealing with the harsh realities of life in the Stone Age. And yet, they built this. They quarried massive stones. They carved them. They transported them to the site. They erected them in circles, with careful attention to alignment and spacing. And then, after using the site for perhaps 1,000 years, they buried it, deliberately. They filled in the circles with earth and rubble, covering the pillars completely, preserving them for the future. Why? We don't know. The site offers no answers, only questions. But the fact that it exists at all, that it's as old as it is, that it demonstrates a level of organization and craftsmanship that shouldn't exist yet, suggests something profound. It suggests that the neat, linear narrative of human progress, from simple to complex, from primitive to advanced, is wrong, or at least incomplete. Because here is complexity, appearing 11,600 years ago, fully formed, with no apparent precedent. And if it can happen once, at a time when we didn't expect it, what else might be hiding in the archaeological record, waiting to be discovered or rediscovered? At Pumapunku, in Bolivia, the precision reaches another level entirely. I mentioned this site earlier, but it deserves more attention, because what you find there is genuinely disturbing if you take the time to think about it. The stones at Pumapunku aren't just fitted together, they're modular. They have interlocking elements, grooves, channels, perfectly flat surfaces that mate with corresponding surfaces on adjacent blocks. It looks like industrial manufacture, like pieces made in a factory according to standardized specifications. Some of the cuts are so precise that they're measured not in millimeters, but in microns. The surfaces are polished to a degree that requires, in modern stonework, diamond tools and careful grinding. The right angles are perfect. 90 degrees exactly, no deviation. And again, we're told this was done with bronze chisels and stone hammers. I want you to really think about that. Imagine trying to cut a channel into a block of granite using a copper chisel. Granite is harder than copper. The chisel wouldn't cut the stone would deform the chisel. You'd have to hammer the stone, fracturing it bit by bit, slowly abrading it away. It's possible, technically, but it's slow, painstaking work, and it doesn't produce mirror-smooth surfaces or perfect right angles. So how was it done? Some researchers have suggested sonic tools, devices that use vibration to cut stone more efficiently than mechanical tools. Others propose chemical methods, ways of softening stone temporarily to make it easier to shape. These ideas are speculative, unsupported by hard evidence, and widely dismissed by mainstream archaeology. But the stones are there, the precision is there. And until someone can demonstrate, convincingly, how these results were achieved with Bronze Age technology, the mystery remains. There are dozens of other sites I could mention. The massive stone spheres in Costa Rica, perfectly round, some weighing over 16 tons. The dolmens of the Caucasus, with stones balanced in configurations that seem to defy gravity. The underground cities of Cappadocia, carved deep into soft rock, with ventilation shafts and complex layouts that suggest long-term planning and engineering knowledge. Each one, taken individually, can be explained away. Natural processes, human ingenuity, misidentification of geological features, but taken together, they form a pattern of ancient construction that's more sophisticated, more precise, and older than we expect. And that pattern points to a possibility that's both thrilling and unsettling, that there was knowledge in the ancient world that we've lost. Knowledge of engineering, of mathematics, of materials, of construction techniques. Knowledge that was either discovered independently by ancient peoples, who were far more capable than we give them credit for, or inherited from an earlier source. A source that time has erased, but whose legacy remains in stone, scattered across the world, waiting for us to recognize it for what it is. So far, we've talked about structures, myths, and the possibility of lost civilizations, but we haven't addressed the most important question: what happened? If there was an advanced culture before recorded history, why did it disappear? What could cause a civilization to vanish so completely that barely a trace remains? The answer might lie in the sky. Around 12,800 years ago, something catastrophic happened to the Earth. The climate, which had been gradually warming as the Ice Age ended, suddenly reversed. Temperatures plummeted. Glaciers that had been retreating began to advance again. Entire ecosystems collapsed, and across North America, Europe, and parts of Asia, large animal species began to go extinct at an alarming rate. This period is called the Younger Dryas, named after a cold-adapted plant that suddenly reappeared in the fossil record during this time. It lasted for about 1,200 years, a brief but intense return to Ice Age conditions. And then, just as suddenly as it began, it ended. Temperatures shot back up, the ice retreated again, and the world we know today began to take shape. For decades, the accepted explanation for the Younger Dryas was that melting ice sheets disrupted ocean currents, particularly the Atlantic meridional overturning circulation, which carries warm water from the tropics to the North Atlantic. When this current was disrupted, the theory goes, it caused rapid cooling in the northern hemisphere. It's a reasonable hypothesis. There's evidence from massive freshwater outflows from melting ice sheets around the right time. And disrupted ocean currents could, in principle, cause significant climate change. But there are problems with this explanation. The cooling was too fast, too widespread, too synchronized. Ocean circulation changes tend to be gradual, even when triggered by sudden events, and they primarily affect regional climates, not global ones. The Younger Dryas, however, appears to have affected the entire planet almost simultaneously. So what else could cause such rapid, dramatic climate change? In recent years, a new hypothesis has emerged, one that's both exciting and terrifying: the Younger Dryas Impact theory. The idea is this. Around 12,800 years ago, a comet or asteroid, or more likely, multiple fragments of a comet, struck the Earth. Not a single large impact, but a swarm of objects, probably broken apart by tidal forces as they approached the planet. These fragments rained down across North America, Europe, and possibly other regions, causing massive explosions, widespread fires, and catastrophic environmental damage. This isn't science fiction. It's not wild speculation. It's based on physical evidence that's been accumulating over the past 2 decades from dozens of sites around the world. The evidence includes: first, a thin layer of sediment found at numerous locations across the northern hemisphere, dated to exactly 12,800 years ago. This layer contains materials that don't occur naturally in those concentrations. Nanodiamonds, which form only under extreme pressure and temperature. Carbon spherules, tiny balls of carbon created by intense heat. High concentrations of iridium and platinum, elements that are rare on Earth's surface, but common in asteroids and comets. And melt glass, created when rock is heated to temperatures exceeding 2,000 degrees Celsius. Second, widespread evidence of massive wildfires at the same time. Charcoal and soot layers appear suddenly in the geological record across North America, suggesting that huge areas of forest were burned almost simultaneously. The scale of these fires is consistent with the thermal radiation from aerial explosions, like the one that occurred in Tunguska, Siberia in 1908, when a small asteroid or comet fragment exploded in the atmosphere, flattening trees across 2,000 square kilometers. Third, the sudden extinction of numerous large mammal species in North America. Within a very short time frame, possibly just a few years or decades, mammoths, saber-toothed cats, giant ground sloths, dire wolves, and dozens of other species disappeared. The extinction was so rapid and so complete that it's hard to explain by climate change alone. Something more dramatic, more catastrophic, seems to have happened. And fourth, the legends. Indigenous cultures across North America have stories of fire falling from the sky, of a time when the sun was blocked out, when darkness covered the land, when the world was destroyed and remade. These stories have been dismissed as myths, as symbolic narratives. But what if they're memories? What if they're describing something that actually happened? The impact theory is controversial. Not all scientists accept it. Some argue that the evidence is ambiguous, that the materials found in the sediment layer could have natural explanations, that more data is needed before we can draw conclusions, but the evidence keeps accumulating. Every year, new sites are discovered with the same characteristic markers, and slowly, the theory is gaining acceptance, not as proven fact, but as a serious hypothesis worthy of further investigation. If the impact occurred, the consequences would have been devastating, beyond imagination. The explosions would have incinerated everything within hundreds of kilometers of the impact points. The heat would have triggered massive firestorms, sending smoke and ash into the atmosphere, blocking out the sun and causing temperatures to plummet. The impact would have melted large sections of the ice sheets, causing catastrophic flooding as meltwater rushed into the oceans. And if there was a civilization at that time, particularly one located along coastlines or in the impact zones, it would have been obliterated. Not damaged, not weakened. Obliterated. Think about what this means. Imagine you're living in a thriving society 12,800 years ago. Your people have built cities, developed agriculture, created art and technology. You have trade networks that span continents. You have accumulated generations of knowledge. And then, one day, the sky catches fire. Objects streak across the heavens, brighter than the sun. They explode in the atmosphere with the force of hundreds of nuclear bombs. The shock waves flatten everything in their path. The heat ignites forests, crops, buildings. Within hours, your world is burning. And then, the ice begins to melt. Not over centuries, but over days and weeks. Massive walls of water surge across the landscape, drowning everything that survived the initial impacts. The coastlines, where most of your people live, disappear beneath the waves. Inland, the sun is hidden by smoke and ash. Temperatures drop. Crops fail. Animals die. The survivors, if there are any, are scattered. They're traumatized. They're reduced to struggling for basic survival. The knowledge, the technology, the accumulated wisdom of your civilization begins to fade. Within a generation, much of it is lost. Within a few generations, it becomes myth. And within a dozen generations, it's forgotten entirely. Remembered only in stories about a time before the flood, a golden age that ended in fire. This is not fantasy. This is a plausible reconstruction of what might have happened based on the physical evidence we have. And if it happened, if a catastrophe of this magnitude struck at the end of the Ice Age, and the absence of archaeological evidence for advanced pre-flood civilizations makes perfect sense, because they were erased, not gradually, not through slow decline, but suddenly and violently. Their cities were destroyed, their people were killed or scattered, and their knowledge was lost, preserved only in fragments, in myths and legends, and the occasional unexplained structure that somehow survived. This is the great filter applied to human history. The idea that civilizations can reach a certain level of development and then be wiped out by forces beyond their control. And if it happened once, it can happen again. If you want to find evidence of a pre-flood civilization, the worst place to look is on land. Because land is dynamic. It's constantly being reshaped by erosion, by vegetation, by tectonic activity. Rivers change course, mountains rise and fall, coastlines shift, Over thousands of years, the landscape transforms completely, and anything that was on the surface, anything that wasn't buried or protected, gets ground down, scattered, or simply disappears. But the ocean floor is different. When sea levels rose at the end of the Ice Age, submerging vast stretches of coastal land, those landscapes were buried under sediment and water. In many cases, the conditions were perfect for preservation. No oxygen to cause decay, no weathering from wind and rain, no human activity to disturb the sites, just stillness and silence, and the slow accumulation of sediment layers. This is why marine archaeology might hold the key to rewriting human history. The problem is, we've barely started looking. The ocean covers 71% of the Earth's surface. It contains 99% of the living space on the planet, if you measure by volume, and we've explored less than 10% of it. Most of the seafloor remains unmapped at any meaningful resolution. We have better topographic maps of Mars, Venus, and the Moon than we do of our own ocean floor. Why? Because ocean exploration is hard, it's expensive, it's technically challenging. The pressures at depth are enormous, the distances are vast. And there's been little economic incentive to explore areas that don't contain obvious resources, like oil, gas, or minerals. But that's starting to change. New technologies, better sonar, autonomous underwater vehicles, improved satellite imaging are making it possible to survey the ocean floor in ways that weren't feasible even a decade ago. And as we look more carefully, strange things keep appearing. In 2001, a team of researchers working off the coast of Cuba, using side-scan sonar, detected what appeared to be a complex of geometric structures at a depth of over 2,000 feet. The sonar images showed linear features, possible pyramids, right angles, and regular spacing that was difficult to explain as natural geology. The discovery was announced. It made headlines. Plans were made for follow-up expeditions with remotely operated vehicles that could capture high-resolution video and take samples. And then, the project stalled. Funding became an issue. Political complications arose. And despite repeated attempts by the original researchers to secure support for continued exploration, the site has never been properly investigated. The sonar images are still there. They're still unexplained. And they sit in the archives, a tantalizing mystery that might be geological, might be archaeological, or might be something we don't yet understand. Off the coast of Okinawa, Japan, the Yonaguni Monument has been the subject of debate for decades. First discovered by a dive operator in 1986, the formation consists of massive sandstone blocks arranged in terraces with flat surfaces, right angles, and what appear to be carved steps and channels. Some geologists argue it's entirely natural, formed by tectonic activity and erosion along natural bedding planes in the rock. Others, particularly those who've studied the site extensively underwater, insist that at least some of the features are too regular, too geometric, to be explained by natural processes alone. The debate continues, with both sides presenting evidence and arguments. But here's what we know for certain. The formation exists. It's approximately 10,000 years old, based on when sea levels rose enough to submerge it. And whether it's natural or man-made, it demonstrates that the ocean hides features that challenge our assumptions about what's possible in the ancient world. In the Gulf of Cambay, Off the western coast of India, marine archaeologists have identified what appear to be extensive structural remains spread over an area of 5 square miles, now submerged under 120 feet of water. Using sonar and dredging operations, they've recovered pottery fragments, pieces of wood, and what appear to be worked stones. Carbon dating of the materials, particularly the wood, has produced some startling results. Ages ranging from 7,500 to over 9,500 years old. If these dates are correct, if the structures are as old as the dating suggests, then we're looking at evidence of organized human activity millennia before the rise of Sumerian civilization, before the unification of Egypt, before anything we currently recognize as civilization in the historical record. The findings had been controversial, as you might expect. Critics question the dating methods, suggest that the artifacts might have been washed into the area from elsewhere, point out that no definitive architectural features have been clearly documented, and they're right to be skeptical. Extraordinary claims require extraordinary evidence, and at this point, the evidence from Cambay is suggestive, but not conclusive. But here's the thing: controversy and skepticism are good. They're essential to the scientific process. What's not good is when potential discoveries are ignored or dismissed without proper investigation simply because they don't fit the established narrative. There are dozens, perhaps hundreds, of underwater anomalies that have been detected by sonar but never properly explored. Unusual formations off the coast of Japan, India, the Mediterranean, the Caribbean, the North Sea. Most will turn out to be natural. Some might be misidentified geological features, but some might be real. Some might be the ruins of settlements, forts, or structures built when these areas were dry land. And we won't know which is which until we look. Really look. Not with brief, underfunded expeditions that barely scratch the surface, but with sustained, systematic surveys using the best technology available. Consider Doggerland, a region that now lies beneath the North Sea, but was once a vast landmass connecting Britain to continental Europe. During the Ice Age, when sea levels were lower, Doggerland was a habitable plain with rivers, lakes, hills, and abundant wildlife. Archaeological evidence suggests it was home to human populations for thousands of years. Then, around 8,200 years ago, a massive underwater landslide off the coast of Norway triggered a tsunami. The Storga Slide, as it's called, sent a wall of water crashing into Doggerland. Within hours or days, much of the region was inundated. And as sea levels continued to rise, the entire area was submerged. An area roughly the size of England vanished beneath the waves. If there were settlements in Doggerland, and there almost certainly were, they're now underwater, buried under sediment, lost to history. Fishermen occasionally dredge up bones, tools, and worked flint from the North Sea, remnants of the people who once lived there. Archaeologists have begun using seismic data to map the buried landscape, revealing river valleys, coastlines, and what might be ancient settlements. But Doggerland is just one submerged landscape, one example. How many others are there? How many ancient coastlines, now hundreds of feet underwater, once supported human populations? How many cities, harbors, monuments lie buried beneath the sediment of the continental shelves? The answer is, we don't know. We've barely started to find out, and until we do, until we systematically explore the submerged landscapes that were once the most desirable places for human habitation, we can't claim to have a complete picture of human history. This is why the ocean matters, not because it's likely to contain evidence of fantastical lost continents or advanced technological civilizations with flying machines and energy weapons, but because it almost certainly contains evidence of human activity that predates the accepted timeline. Evidence of people living, building, trading, organizing themselves in ways we haven't accounted for. Evidence that, if found and properly documented, would force us to rethink when and how complex human societies emerged. And maybe, just maybe, evidence of something more. Something that our myths and legends have been trying to tell us about for thousands of years. The memory of a world that was lost beneath the waves. Even if we accept the possibility that there were advanced civilizations before the flood, before the impacts, before the catastrophics that reshaped the world, there's still a crucial question: how did any knowledge survive? If these civilizations were destroyed so completely, if their cities were buried and their people scattered, how did any of their achievements make it through to later generations? The answer might lie in something we often overlook: the survivors. And more specifically, what those survivors carried with them. Not just tools or artifacts, but knowledge, information, skills, and the determination to preserve them despite the loss of everything else. Throughout history, when civilizations collapse, what survives is rarely the grand monuments or the elaborate technology. What survives is the knowledge carried, or what survives is the knowledge carried by people, passed down through stories, through teaching, through careful preservations of the most essential wisdom. And sometimes that knowledge gets encoded in ways that transcend language and culture, in structures, in mathematics, in astronomical alignments, in symbols and patterns that can be recognized and understood even by people who don't share the same language or cultural context. This might explain some of the anomalies we've been discussing: the advanced mathematics in the pyramids, the astronomical knowledge of the Maya, the precise alignments of megalithic sites. These might not be the inventions of the cultures we associate with them. They might be inheritances, knowledge that was passed down from an earlier time, preserved and maintained by people who understood its value, even if they didn't fully understand its origins. Let's look at some specific examples. The Antikythera mechanism. This is one of the most extraordinary artifacts ever recovered from the ancient world. It was discovered in 1901 in a shipwreck off the coast of Greece. At first, it appeared to be just a corroded lump of bronze. But as researchers carefully examined it, using X-rays and modern imaging techniques, they realized it was something remarkable: a mechanical computer. The device dates to around 100 BCE. It consists of a complex system of bronze gears, at least 30 of them, carefully crafted and assembled to perform astronomical calculations. It could predict the positions of the sun, moon, and planets. It could calculate eclipses. It could track the ancient Olympic Games. It was, in essence, a portable astronomical calculator of extraordinary sophistication. The level of engineering is astonishing. The gears are precisely cut, with triangular teeth that reduce wear and allow for smooth operation. The mechanism uses a differential gear, a device that wasn't supposed to be reinvented until the 16th century. And the astronomical knowledge encoded in the device is accurate and detailed. reflecting centuries of observation and calculation. Here's the puzzle. The Antikythera mechanism exists in isolation. We don't have other examples of devices like it. We don't have records describing how it was made or what tradition of engineering it emerged from. It appears suddenly in the historical record, fully formed, impossibly advanced for its time, and then it disappears. The knowledge of how to create such devices seems to have been lost, not to be recovered until well over 1,000 years later. How do you explain this? One possibility is that it was a unique invention, created by a genius engineer who figured out principles of mechanical computation far ahead of his time. But that seems unlikely. Devices this sophisticated don't appear out of nowhere. They emerge from traditions of craftsmanship, from gradual refinement of techniques, from accumulated knowledge passed down through generations. So maybe the Antikythera mechanism wasn't created from scratch. Maybe it was based on earlier designs, earlier knowledge that was already ancient when the device was built. Knowledge that had been preserved and handed down from an earlier time, from people who understood astronomy and mechanics at a level that would later be forgotten. Or consider the Piri-Reis map. We talked about this earlier, but it's worth examining in more detail because it represents something profoundly strange, knowledge that shouldn't exist. Admiral Piri-Reis was a Turkish naval commander who, in 1513, created a world map. He noted on the map itself that he compiled it from 20 earlier source maps, some dating back to the time of Alexander the Great, some from Arab cartographers, some from Portuguese sailors. The map shows the coastlines of Europe, Africa, and South America with remarkable accuracy for the time. But the most striking feature is in the southern portion of the map. It shows a coastline that appears to be Antarctica. Antarctica wasn't officially discovered until 1820, over 300 years after the Piri-Reis map was created. And even after its discovery, the true coastline remained largely unknown because it's buried under ice sheets that are, in places, over 2 miles thick. The Piri-Reis map doesn't just show Antarctica, it shows it ice-free. And when researchers have compared the coastline on the map to modern surveys of the subglacial topography of Antarctica, conducted using ground-penetrating radar and seismic techniques, the match is startling. Mountains, bays, rivers, features that exist beneath the ice, are depicted on a map made in 1513. How is this possible? The conventional explanation is that it's coincidence. That Piri-Reis was drawing speculative geography, filling in blank areas on his map based on rumors and imagination, and by chance created something that vaguely resembles Antarctica. But the accuracy is too good for coincidence. The features are too specific. And, besides, Piri-Reis himself says he's copying from earlier sources. He's not inventing, he's compiling. So, if the map is accurate, and if it's based on older sources, as Piri-Reis claims, then someone, at some point in the past, had detailed knowledge of Antarctica's coastline. And the only time that coastline was visible, not hidden under ice, was thousands of years ago, perhaps 6,000 years ago, perhaps earlier. Who mapped it? And how did that knowledge survive, passed down through generation after generation, century after century, eventually finding its way onto a Turkish admiral's desk in the 16th century? We don't know. But the map exists, and it's not alone. The Orientius Phineas map from 1531 also shows Antarctica, again with features that match the subglacial topography. The Boash map from 1737 shows Antarctica divided into two landmasses by a channel of water, which is exactly what lies beneath the ice sheet in that region. These aren't forgeries. They're historical documents, authenticated and studied by cartographers and historians, and they represent a mystery that we haven't solved. A mystery that suggests knowledge was being preserved and transmitted from the ancient world in ways we don't fully understand. Or think about the astronomical knowledge of ancient cultures. The Maya tracked the movements of Venus with extraordinary precision, calculating its cycle to within hours over centuries. They understood the precession of the equinoxes, a slow wobble in Earth's axis that takes 26,000 years to complete. This requires not just observation, but centuries of accumulated data, careful record-keeping, and sophisticated mathematical analysis. The ancient Egyptians aligned their temples and pyramids to specific stars with incredible accuracy. The shafts in the Great Pyramid are aligned to Orion's belt and to the star Sirius. The Temple of Abu Simbel is oriented so that twice a year, on specific dates, sunlight penetrates deep into the interior, illuminating statues of the pharaoh and the gods. This isn't accidental. It requires knowledge of astronomy, geometry, and engineering. The builders of Stonehenge created a structure that marks solstices and eclipses, that tracks the movements of the sun and moon with precision. And they did this 4,500 years ago, supposedly using only stone tools and basic surveying techniques. How did these cultures acquire such detailed astronomical knowledge? How did they develop the mathematics necessary to make accurate predictions? And why was this knowledge so important to them that they encoded it in stone, in structures designed to last for millennia? One possibility, the conventional one, is that they figured it out themselves. Through patient observation, careful record-keeping, and intellectual brilliance, ancient astronomers mapped the heavens and understood the cycles of celestial bodies. But another possibility is that they inherited it, that the knowledge came from an earlier source, a tradition of astronomical observation that stretched back much further than we recognize. A tradition that might have been disrupted by the catastrophes at the end of the Ice Age, but wasn't entirely lost. Knowledge that survived in the hands of a few, passed down carefully, reverently, because those who carried it understood its value. This is the idea of knowledge carriers, people who preserve information across generations, across catastrophes, across the collapse of civilizations. We see this pattern throughout history. When Rome fell, it was monks in monasteries who preserved classical texts, copying them by hand, protecting them from the chaos outside. When the Library of Alexandria burned, scholars scattered, taking with them what they could salvage of its accumulated wisdom. And maybe, just maybe, when the ancient world was destroyed by floods and impacts and climate catastrophe, there were survivors who did the same, who carried with them the most precious knowledge of their civilization, astronomy, mathematics, engineering principles, maps, stories, who passed it down to their children and their children's children, became, in the myths of later cultures, the culture heroes, the wise ones, the gods who came from across the sea to teach the arts of civilization. This would explain why so many ancient cultures have stories of these figures. The Sumerians spoke of the Apkallu, 7 sages who came before the flood and taught humanity the arts of civilization. The Egyptians had Thoth, the god of wisdom and writing. The Maya had Kukulkan, the feathered serpent who brought knowledge. The Incas had Viracocha, who taught agriculture and architecture. In every case, these figures are described as coming from a time before, from a civilization that was destroyed, bringing with them knowledge that allowed the survivors to rebuild. And in every case, they're depicted not as gods in the supernatural sense, but as teachers, as people with extraordinary knowledge who chose to share it. Are these just myths, symbolic stories about the origins of culture, or are they distorted memories of real people, survivors of real catastrophes, who carried real knowledge into the post-catastrophe world? We can't know for certain. But the pattern is there, and it's consistent across cultures that had no contact with each other, cultures separated by oceans and millennia. Maybe the knowledge didn't survive intact. Maybe it degraded, becoming fragmented and distorted over time. But maybe enough survived to give later civilizations a head start, a foundation to build on. Maybe that's why civilization seems to appear so suddenly, why complex societies emerge with sophisticated knowledge already in place. Not because they invented everything from scratch, but because they inherited pieces of something older. This is not ancient astronauts. This is not alien intervention. This is humans helping humans across the chasm of catastrophe. This is knowledge surviving against all odds, carried by people who refused to let it die. And if that's what happened, if there were knowledge carriers who preserved the wisdom of the pre-flood world, then the monuments and the maps and the mathematical constants encoded in ancient structures aren't just impressive achievements. They're messages, deliberate attempts to preserve information in a form that would survive, that would be recognized by future generations, that would say, we were here, we knew things, and we tried to pass it on to you. There's a concept in the search for extraterrestrial intelligence called the Fermi paradox. It's named after the physicist Enrico Fermi, who supposedly asked over lunch one day, "Where is everybody?" The question is simple but profound. The universe is vast, containing hundreds of billions of galaxies, each with hundreds of billions of stars. Many of those stars have planets, and on at least some of those planets, conditions should be suitable for life. Given the age of the universe, roughly 13.8 billion years, and the age of our galaxy, about 13 billion years, intelligent civilizations should have had plenty of time to emerge, develop technology, and spread across the galaxy. Even with relatively slow speeds, a civilization could colonize the entire Milky Way in just a few million years, which is a blink of an eye in cosmic terms. So where are they? Why haven't we detected any signals? Why haven't we found any evidence of megastructures, terraformed planets, or interstellar travel? Why does the universe seem so empty? One proposed answer to the Fermi paradox is the Great Filter hypothesis. It suggests that somewhere between the emergence of life and the development of galaxy-spanning civilizations, there's a barrier, a filter, something that prevents most life from progressing beyond a certain point. The filter might be behind us. Maybe the jump from non-life to life is extraordinarily rare. Maybe the evolution of complex multicellular organisms is a fluke. Maybe intelligence itself is an unlikely accident. Or maybe the filter is ahead of us. Maybe civilizations tend to destroy themselves once they reach a certain level of technological capability. Maybe they exhaust their resources or wage catastrophic wars, or accidentally create technologies they can't control. Maybe they're wiped out by natural disasters, cosmic impacts, or climate change before they can become spacefaring. If the filter is ahead of us, that's deeply troubling. It suggests there's something inherently unstable about technological civilizations, something that causes them to fail before they can establish a permanent presence beyond their home planet. But here's the thing, the Great Filter doesn't just apply to the galaxy. It applies to individual planets as well, including Earth. Because when you look at the geological and archaeological record, When you consider the evidence we've been discussing, a pattern emerges. A pattern that suggests civilizations on Earth might rise and fall in cycles, each one reaching a certain level of development before being knocked back by forces beyond their control. The Younger Dryas Impact, the flood at the end of the Ice Age. The climate instabilities and catastrophes that reshaped the world just as humans were beginning to organize into complex societies. These weren't just random events, they were filters. Natural mechanisms that reset the clock, that wiped out whatever progress had been made, that forced survivors to start over with limited resources and fragmentary knowledge. And if it happened then, it can happen again. To us. We live in a moment of extraordinary fragility. We've built a global civilization that depends on complex, interconnected systems, supply chains that span continents, energy grids that can be disrupted by a solar flare, communication networks that rely on satellites vulnerable to space debris, agricultural systems optimized for efficiency but brittle in the face of climate change. A major catastrophe, a large asteroid impact, a supervolcanic eruption, a pandemic far deadlier than COVID, could unravel this system frighteningly quickly, not destroy humanity necessarily, but knock us back, scatter our populations, disrupt our ability to maintain the knowledge and technology we've accumulated. And if that happened, if we lost the infrastructure of modern civilization, how much of our knowledge would survive? How much could be preserved without computers, without the internet, without printing presses, and universities and research institutions? Less than you might think, because most of our knowledge exists in fragile forms, books that decay, hard drives that fail, specialized knowledge held by a small number of experts who might not survive the catastrophe. Within a generation or two, much of what we know could be lost. Within a few generations, it could become myth. This is the cycle. This is the filter. Not something that destroys intelligence completely, but something that prevents it from becoming permanent, from establishing itself beyond the reach of catastrophe. And maybe we're not the first to face this challenge. Maybe others have tried before us. Maybe they reached a similar level of development, looked up at the sky with the same questions we're asking, and then were swept away by events they couldn't predict or control. This is why the question of lost civilizations matters. Not because we need to prove or disprove a historical hypothesis, but because understanding what happened in the past might help us survive the future. If there were earlier civilizations, if they faced similar challenges, if they left warnings or preserved knowledge in ways we're only beginning to recognize, then we need to find that information. We need to understand what they learned, what mistakes they made, what solutions they discovered, and we need to prepare. Because the filter is still there. The threats haven't disappeared. Asteroids still cross Earth's orbit. Supervolcanoes still simmer beneath Yellowstone and other locations around the world. The sun still produces flares that could disable our electrical grids. Climate change continues to accelerate, with consequences we're only beginning to understand. We have two advantages that previous civilizations might not have had. First, we have the ability to detect some of these threats in advance. We can track asteroids, monitor volcanoes, model climate systems. We're not blind to the dangers, even if we're not yet fully prepared to deal with them. And second, we have the ability to preserve knowledge in ways that might survive catastrophe. We can encode information in multiple formats, store it in multiple locations, create redundancy. We can put archives in stable geological formations, etch data onto metal plates designed to last millions of years, send information into space where it's beyond the reach of earthly disasters. But we have to choose to do these things. We have to recognize that our civilization, impressive as it is not permanent. That everything we've built is terrible for us to be false. That preserving knowledge, preparing for disasters, and understanding our own history aren't luxuries, but necessities. This brings us back to where we started. The question of whether there were civilizations before ours isn't just an academic curiosity, it's existential. Because if the answer is yes, if we're not the first to reach this point, then we need to understand what happened to them. We need to learn from their experiences. We need to make sure we don't repeat their mistakes. And if the answer is no, if we are the first, then the responsibility is even greater. Because we're blazing a trail that others might follow. We're the test case. The proof that intelligence can emerge, can develop technology, can ask questions about the universe and its own place within it. The question is whether we can survive long enough to answer those questions. Whether we can navigate the filter that has stopped others, or might have stopped others before us. So, where does this leave us? After all, we've explored all the evidence and speculation, all the unanswered questions. What are we supposed to do with this information? First, we need to be honest about what we don't know. The truth is, we have fragments. Pieces of a puzzle that might not even exist. Structures that are older and more sophisticated than expected. Myths that describe catastrophes with geological corroboration. Maps that show coastlines that shouldn't be known. Astronomical knowledge that seems too advanced for its time. Taken individually, each piece can be explained away or dismissed. But taken together, they form a pattern. Not proof, but a pattern. And that pattern suggests the possibility, not the certainty, but the possibility that human history is longer, more complex, and more cyclical than the standard narrative acknowledges. Second, we need to keep looking. The ocean floor remains largely unexplored. The submerged continental shelves, where pre-flood civilizations would have lived, are still hidden beneath sediment and water. Archaeological sites continue to be discovered that push back the timeline of human capability. And new technologies, better dating methods, improved imaging techniques are giving us tools to examine the past in ways that weren't possible even a decade ago. We should be funding this research properly, not as a fringe pursuit, but as a legitimate effort to understand our own history. Because even if we don't find evidence of lost civilizations, we'll still learn valuable things about human development, about how societies organize and evolve, about how catastrophes shape the trajectory of cultures. And if we do find evidence, if we discover clear proof that there were advanced societies before the flood, before the Ice Age, before recorded history, then we'll have to rewrite the textbooks. We'll have to fundamentally rethink our understanding of human progress. But that's okay. That's how science works. That's how knowledge advances, by being willing to question assumptions and follow evidence wherever it leads. Third, we need to preserve what we have. Not just archaeological sites and artifacts, but knowledge itself. We're living through a period of unprecedented information accumulation. We know more about the universe, about Earth, about ourselves than any previous generation in history. But most of that knowledge exists in fragile formats. Digital storage degrades, hard drives fail, servers go offline. Cloud services depend on saving food. and calls us 7 raids. We'll see. If our technological infrastructure were disrupted for even a few years, much of our accumulated knowledge could be lost, not because it was destroyed, but because it became inaccessible. We need to create durable archives, physical libraries of the most important information, stored in stable environments, written in formats that don't require complex technology to access. We need to think about how future generations, possibly generations that might not have our level of technology, could access and understand what we've learned. Projects like the Arctic World Archive, which stores data on film reels in a frozen vault in Svalbard, Norway, are a good start. But we need more. We need distributed backups, multiple redundancies, formats that will survive not just decades, but millennia. And we need to encode knowledge in ways that transcend language and culture. Because if there is a catastrophe, if civilization does get knocked back, the survivors might not speak English or any modern language. They'll need information they can understand, information presented in universal terms, mathematics, geometry, astronomical observations, images and diagrams that communicate across the barriers of time and culture. This isn't paranoia. It's prudence, because history, both recorded and geological, shows us that catastrophes happen, that civilizations fall, that knowledge can be lost, and that when it is lost, it takes centuries or millennia to recover, if it's recovered at all. Fourth, we need to prepare for the threats we know about. Asteroid impacts aren't science fiction. They've happened before. They'll happen again. The question is whether we'll have the capability to detect and deflect them when the time comes. NASA's recent DART mission, which successfully altered the trajectory of an asteroid by crashing a spacecraft into it, is a proof of concept. It shows that planetary defense is possible. But we need to invest more in detection systems, in developing deflection technologies, in building the infrastructure that would allow us to respond to a threat with years or decades of lead time. Similarly, we need to take climate change seriously, not as a political issue but as an existential one, because climate instability has toppled civilizations before. The collapse of the Bronze Age civilizations, around 1200 BCE, the fall of the classic Maya, the end of the Akkadian Empire, all of these are linked to climate change, to droughts and shifting weather patterns that disrupted agriculture and caused social upheaval. We have the knowledge and the technology to mitigate climate change, to adapt to its effects, to build resilient systems that can withstand disruption. But we need the will to do it, and we need to do it now, before the changes become so severe that adaptation is no longer possible. Finally, we need to maintain our sense of wonder, because that's what drives discovery. That's what pushes us to ask uncomfortable questions, to look for evidence in unlikely places, to imagine possibilities that seem far-fetched but might be true. The question of lost civilizations, whether they existed or not, reminds us that history is not a closed book, that there are still mysteries to solve, still discoveries to be made, still pieces of the human story waiting to be uncovered. And it reminds us of our place in the vast sweep of time. We are, each of us, a single point in a line that stretches back hundreds of thousands of years and forward, we hope, much further. We're connected to everyone who came before, to the people who painted caves in Lascaux, who carved stones at Göbekli Tepe, who built the first cities, who looked up at the stars and wondered what they were. And we're connected to everyone who will come after, assuming we survive, assuming we navigate the challenges ahead. The knowledge we preserve, the choices we make, the care we take to understand our past and prepare for our future, all of this will shape what comes next. So let's stay curious. Let's keep asking questions. Let's be willing to challenge assumptions and follow evidence, even when it leads to uncomfortable conclusions. Because the truth, whatever it is worth pursuing. And the story of humanity, in all its complexity and depth, deserves to be told as completely as possible. And so we arrive at the end of our journey, here in the quiet hours when the world feels both ancient and new. We've walked through ruins and myths, through geology and catastrophe, through questions that have no easy answers. Maybe we are the first, maybe the structures, the anomalies, the myths, all have mundane explanations that we just haven't found yet. Maybe human civilization really did begin 5,000 years ago, springing fully formed from the mind of the first farmer who looked at wild grain and imagined something more. Or maybe we're not the first. Maybe the Earth has seen this before, this spark of consciousness that looks up at the stars and asks why. Maybe others have stood where we stand now, on the edge of understanding, reaching for knowledge, building monuments to their achievements, and then being swept away by forces they couldn't control. We don't know, and in a way, that's the point. Because the not knowing, the uncertainty, the vast unexplored spaces in our own history, that's where wonder lives. That's where curiosity thrives. That's where the next discovery waits, patient and silent, for someone brave enough to look. I want you to take something with you as you close this video and return to your life. Not certainty, not a conclusion, but a question. A small seed of doubt about the narratives we accept without question. The next time you see a documentary that confidently declares when civilization began, ask yourself, how do they know? What evidence are they basing that on? What assumptions are they making? The next time you read about an ancient structure that supposedly took decades to build with primitive tools, ask yourself, is that really the only explanation? Have we tried to replicate it? And if we can't replicate it, what does that tell us? The next time you hear a myth dismissed as fantasy, ask yourself, what if there's a kernel of truth in there? What if the people who told these stories were trying to preserve something real, something important, in the only way they knew how? Stay curious, my friends. Stay skeptical of easy answers, and remember that the past is not dead. It's not even past. It's still here, buried beneath the waves, scattered across deserts, encoded in stone and star alignments, and stories told around fires. And we, here in the present, are the bridge between what was and what will be. We're the ones who get to decide which knowledge survives, which questions get asked, which mysteries get pursued. Thank you for spending this time with me, for following these questions into the dark. If this resonated with you, if you find yourself still thinking about these ideas tomorrow and the day after, then please subscribe to Next Documentaries. Because we're not done asking. The night is long, and there are more mysteries waiting. Where do you stand? Are we the first, or are we just the latest chapter in a much longer story? I don't have the answer, but I know where I'll be looking. Down, under the waves, between the myths. in the places where history and mystery blur together. Sleep well tonight, seeker. And remember, just because we've forgotten something doesn't mean it never existed. The earth keeps its secrets. But sometimes, if we listen carefully, it whispers them back to us. Until next time, this is Nick's Documentaries. Stay curious, stay questioning, and never stop looking for the truth, even when it hides in the shadows between what we know and what we've forgotten. Good night.
IHHACHA72. Good night.